both of them are like similar in level. But I think what we've learned from previous questions is, generally speaking, we tend to make the bottom equal to u, don't we? So I'd be inclined to follow the same pattern. So I'm going to say that the u value is ex plus 1. Differentiate. You still get ex. Move the dx up. There's your ex dx locked in. So you can sub that out immediately. Okay. So, and then it's going to be 1 over u, because you subbed out ex plus 1. And then it's going to be ex dx is just du. Integrate that. Did you get ln u? Replace u with? Yeah. Put in your limits, which are ln 3 and 0. Does anybody know what e to the power of ln does? It's just basically an undo button. So e ln 3 is actually just 3. You can try it out of your calculator if you forget. They basically undo each other. So what's going to be is ln, and this is going to be e ln 3, which is just 3. So it'll be 3 plus 1, which is 4, and then it's going to be minus e to the power 0 is 1. 1 plus 1, 2. ln 4 minus ln 2, use the division rule of logs. ln 4 over 2, which is ln 2. Now, so we know we're in the substitution section. We know we can't integrate this using regular maths. We're not told how to do this, all right? So generally speaking, what I do is I might use the one that has the bigger power. So which one has the bigger power? Huh? Yeah. Now, so I have a choice. Do I want it to be u equals sine x to the power of 3? That actually might work. Or could I just use u equals? I could just use u equals sine x. Might do the trick. I could do sine x to the power of 3. That will probably also do the trick. But it does seem slightly more complicated, doesn't it? I'll show you that they'll both work out to the same thing in a minute. Okay. So what happens if we differentiate the bottom one? What do you get? Du dx equals, and du equals cos x. Differentiate this one just for argument's sake. Chain rule, bring the 3 to the front. Take 1 away from the power, which is power 2. Differentiate the missing sine x. So, to be fair, that one's considerably more complicated and isn't working out nicely. The powers aren't lining up properly. It just seems a bit awkward. While if we chose the smaller bite size, I think we're going to get it out. So we can see there we tried both. One of them wasn't coming out as much as we'd like it. We went to the bottom one. Now look what happens to the bottom one now, right? What happens to cos x dx? Du. What happens to sine x to the power of 3? Yeah. That's handy, isn't it? So what are we thinking now? Integrate that. Add 1 onto the power. Yeah. And what do we know u to the power of 4 actually is? Huh? So it's going to be 1/4 sine 4x, yeah? And what are my limits? Okay. Now this could be one that you put straight into the calculator. So you do 1/4 sine pi over 2 to the power of 4 minus 1/4 sine pi over 4 to the power of 4. I'll let somebody do the calculator there. Let's go and do this the old school way. Alright, that's 1/4. Sine 90 is 1. That's still 1/4. This is 1/4. Sine pi over 4 is 1 over root 2. 1 over root 2 to the power of 4 is actually a quarter. So I essentially have a quarter minus a 16th. And that is 3/16. Here, right? What are our two choices? U equals cos x, yeah? And what do u dx be? Minus sine x. And then du would be minus sine x. What's our other option? U is equal to sine x. Du dx equals. And then du equals. Blue or red? Which one do you think works better? Blue. See the way you have to cos x dx all in the numerator position? Lines up. Sorry, just meant to be an x there. Cos x dx lines up perfectly. While the other option doesn't. There's no minus sign on top. Generally speaking, we tend to use the bottom a lot, don't we? And we tend to get that integrating 1 over u, and that turns into a log. That happens a lot, right? So that's what happens if you run out both scenarios. And I think it's quite obvious that the blue one lined up while the red one didn't. If you can't remember what to do, you can try both scenarios and see which one lines up better. So what are we saying about this then? The sign is on the bottom, 1 over u du. Okay? And then what happens when we integrate that? ln u. And then what happens when we change out the u? ln sine x, yeah? And then this question that looked quite intimidating at first is now looking relatively tame. So what happens now? You reckon? ln sine pi over 2. Sine pi over 2 is 1. So that's ln 1 minus ln sine pi over 6. Sine pi over 6 is sine 30. Sine 30 is a half. So the actual answer is minus ln a half. And you'll need to know this trick because I've seen this done in the past papers before. Do you know what you can turn ln a half into? ln 1 minus. And what is ln 1? Minus ln 2. They've done that before.